3, 2, 1, and action. Hey guys, it's me Vishwant and welcome to a new episode of Modern Campus, wherein we essentially discuss about topics and subjects which aren't taught in normal college classes. So, what is my reasoning behind going into maths of machine learning? Because all people just do is just import libraries in Python without knowing the underlying logic behind it. So all these people do is they just import sklearn, they import PyTorch or TensorFlow, and this they call it a day out. Like, come on, at least know the cost and loss associated in the training process, which hyperparameter to choose, and increase the overall training efficiency of your choice of algorithm. At least you should know the underlying principles and the components that goes into your model training and deployment. Anyways, so in this video we'll have timestamps so that you guys can track your overall progress in this video. So if you like to track back and refer to my video, there will be timestamps mentioned in this video as well. There will be resources which will be marked down in the comment section, above the comment sections, and there will be a pinned comment which will guide you through all the repositories and the websites to follow. I'm finally entering my maths genius era. Like you can see, I have some maths stuff going on over there. So yeah, and to be very fair and honest, on my side, all due credit goes to Andrew Ong, who is a professor at Stanford, and Huan Chip. She has done a very phenomenal job in aggregating machine learning and making it very easy and viable and accessible to all the people out there. So without further ado, let's start. So let's dive into it. So firstly, let's head over to mindset. So talking about mindset, you should have a mindset of a pilot. Be calm, clutter-free, meditate, to be intuitive in nature when it comes to the underlying logic that goes behind maths. So just like a pilot, you should know the weight of an aircraft, speed of the winds, net fuel to set the optimal thrust for your aircraft engine. Same way is with machine learning. You have a lot of insights on your data, and on top of that, you choose the correct model for it. So you have to understand the features mathematically, are the data points continuous or discrete in nature, knowing them unit wise, and then you should proceed to choosing a model and then optimizing its cost and loss function. And yes, you simply cannot ignore maths behind it, because there is a lot of maths that goes under the hood, and it's just it is something which is very underrated. So let's move on to the next section. Moving on to SAP. So SAP actually stands for Statistics, Algebra, and Probability, not the SaaS thing that big corporate houses use like S4HANA for finance and all. I'm talking about Statistics, Algebra, and Probability. So little insights I would like to give you on statistics. You gotta know your mean, difference of mean with a particular data point, which is also called as the variance, and the root over of variance, which is standard deviation, and the central limit theorem. Later on, hop on to covariance and bias, as these are vastly used on neural networks, because there is something called as feed forward and back propagation. So there's some sort of cost and loss function associated with it, and we do add a bias to just add an element of trick to make it more accurate and human-like. So, and lastly, you should hop over to chi-square distribution. It kind of helps in mapping out correlation of features. So that is something we should be covered at the end. So your journey should be from mean all the way to the distribution. So moving on to the algebra part. Know your matrices and vectors well. Know how operations and transformations occur, such as matrix multiplication and its combination with vectors. So little fun story. Numbers inside bracket are vectors, and bunch of vectors are matrices. And you should be very good at matrices, because you can deal a lot with vectors and matrices, because it is something which you cannot escape. Knowing the normalization technique, such as Euclidean, Manhattan techniques, which are used to flatten out inequalities present inside a vector or a matrix. So these things are something which aren't emphasized pretty much, but you should give it a try. I mean, I have also given it a try. That's the reason why I'm making this video. So know your transformation pretty well. So firstly vectors, and then moving on to matrices. So that journey you have to cover. You have to also know the identities which goes into it. Moving on to something which is I believe is the most underrated part of it, which are known as eigenvalues and eigenvectors. These are used to equate the product of a matrix with a vector. So there is some spectral theorem which are being associated with it. So understand the spectral theorem and the relation of the unitary matrix. So you have to understand matrix pretty well, and then an eigenvalue. Moving on to singular value decomposition is a further extension to it. So know your vectors, matrices, normalization techniques, eigenvalues, eigenvectors. Then only you will kind of understand how to use the spectral theorem, and on top of that there will be some singular value decomposition coming down the line. Also, this is something which I'm gonna cover eventually down the line, is the fact that you should understand the matrix calculus as well, in which we have the Hessian gradient, which is using gradient descent algorithm for cost and loss functions. So there would be certain matrices which would be involved in the neural networks, and you have to kind of use calculus. You cannot escape calculus. You have to surrender yourself before entering into machine learning to calculus, because you have to understand your calculus pretty well. Without calculus you cannot optimize your gradient descent algorithm. So understanding the matrix calculus would be a bonus point. Heading on to the probability part, this is something which is very fun. We all have done this back in school. What is the probability of pulling out an ace out of a deck of shuffled 52 cards? You know what I mean. So know your events, outcomes, sample sizes, and after that move on to conditional probability, which is what would be the probability of y if x happens, and that is something which is known as conditional probability. And there's something known as reverse conditional probability. So if we know the conditional probability of event y happening with event x, we can also find the conditional probability of event x happening when there is event y happening, which is the Bayes theorem. That pretty much sums up the probability part. And this is something which I really like, because probability is fun. You can take with numbers and all, and you can create all sorts of scenarios. So moving on to the distribution function, on how does a random value function determines the mapping of a point. So there will be a random value associated, which will help you map the vector points on a planar line. Cumulative distribution function, which is very aggregative in nature. So it kind of is like a sigma function, wherein it is all cumulated up, and then there is this probabilistic distribution function, which is very derivative in nature. So it's calculus is in this as well. So probabilistic distribution is something you need to understand. because cumulative distribution function is an aggregate and a probabilistic distribution function is a derivative of the aggregate. Once your knowledge on these topics is solid in nature, move on to the types of distribution. There's binomial distribution, Poisson distribution, and uniform distribution. And then there are several other I would say types of distribution as well. And the thing is, I'm gonna put visuals so that you guys don't get overwhelmed that I'm just throwing words. And let's move on to something fun, I would say. I'll quote Feynman for this because I'm discussing something which is very important, which is known as from algebra to calculus. So you can't run away from calculus. It pretty much follows you throughout your learning journey in machine learning. Learn the identities on how derivatives and integrals works, like first order derivative, second order derivative, derivative of all the trigonometric functions, all the natural log functions. You should have a very good and a clear idea of it. Get yourself a grade 12, I'm sorry for saying grade 2. Get yourself a grade 12 book or an AP calculus book. AP calculus is for my international audience. Some grade 12 is for my Indian audience. So that is something that you can refer to, transition any area or algebra to calculus journey. Once thorough, learn about partial derivatives, and then the journey becomes relatively easy, because the moment you understand how your partial derivatives work, right, you will get a deep insight and knowledge on how the cost function and the loss function works, and how this overall optimization works. Like, that's pretty self-explanatory, because if you see all of this Medium articles or all of the scientific research that is being displayed, you'll see a lot of calculus and then the model. So get your calculus straight. And I'd suggest, if you're struggling with this, with this journey, you should consider watching the series by Dr. Richard Feynman. I'm pronouncing it right? Dr. Richard Feynman, on From Counting to Algebra. It is like very extensive in nature and you will get the hang of it. So Richard Feynman will literally teach you like how to count. So he will teach you from counting, and then he will transition you into algebra. So once you are very thorough with algebra, then only he will move on to calculus. And once you finish the entire series, you will feel pretty confident about seeing all the numbers, and you will not be overwhelmed by seeing this huge formulas which goes into theory papers and research papers. And then you will get the hang of it on how to optimize your algorithm all in all. So moving on to machine learning concepts. So once you're thorough with the maths, then there is this further extension of maths that you have to be very proficient in, which is like machine learning concepts, because it's not all code and gibberish. You have to follow a particular structure which goes behind this. So firstly, I would recommend you to start with supervised learning. Start with linear regression. Understand the least mean square algorithm, LMS, which is it's pretty convenient, like LMS. Then move on to logistic regression. Understand the algorithms and the difference between one how predicts the trends and other is solely used for classification. And then move on to something a bit more refined, which is the generalized linear models, on how logistic regression is built. Generative linear algorithms, which covers your GDA and naive bias. Kernels are very underrated, by the way. They help you map features. You can say kernel is an abstraction of a random value. Random value that we covered in probability in this SAT section, so you should like check that out as well. And at the end, support vector machines, and which helps you like divide planes. And in support vector machine, there's this concept known as hyperplane optimization. So that is a huge topic in itself. So you can check that out as well. So moving on to deep learning, especially neural networks, learn about weights, biases, cost and loss function, activation function, and move on to the working principles of feed forward and backpropagation algorithms as well. So once you get the hang of the calculus which goes behind this, then only you will realize about how weights and biases work. So like there's this common formula which is y is equal to wx plus b, which is b is bias. B may be a very randomistic in nature or probabilistic in nature, and then there will be some functions like sigma function, that is coming down the line. So deep learning is pretty much vast in itself and it deserves more attention, but you should know the maths which goes behind a neural network. And same goes with backpropagation and feed forward. So there's some cost and loss optimization loop feed, and I'll ping that down as well so that you guys don't get confused. So yeah, moving on to generalization and regularization. So generalization and regularization is necessary to optimize your model performance and to prevent it from overfitting, underfitting, or hallucinations. So once your data is generalized, it is normalized throughout the entire vector or matrix, then only it is optimal to deploy it or train a model on it. And without that, you would just eventually do a lot of overfitting or underfitting with it. So that is something which deserves attention as well. Moving on to unsupervised learning, we have got clustering, k-based, KNN, which is short abbreviation, expectation, maximization, and other stuff, which we need some knowledge of statistics because it happens on a graph. Because unsupervised learning, I have all the problems that I see. It's on a graph, report map project or type plot as PMT, and then you have this huge clusters, and then there's this 990 clusters, KML, similar stuff. Also, principal component analysis, which is a glorified version of dimension reduction. So we use dimension reduction when we have computational limitations. So that is something which you should put emphasis on. And lastly, I would go for reinforced learning. I would say it is just a side project of Andrew Markov. Just kidding. It depends upon the Markov's assumption, which states that past doesn't determine the future, but the future state, but it is the current state which determines the trajectory of the future state, and add a little bit of MDP on the side as well. So actually, on a very fun fact, I have Markov's assumption up over here. I'll actually add a picture of it as well, so that you guys can see that that's something cool. And lastly comes the resources part. So it is I'll keep it very lean when it comes to resources. Firstly, grab yourself some paper because let's say grab yourself some paper. Once you grab yourself some paper, have a TI-84 calculator or any scientific calculator, because you will deal with a lot of calculus. And yeah, you should definitely check out Stanford CS229 by Andrew Arnold, because it is very vast when it comes to the concepts which are important in machine learning. CS229 by Andrew Arnold is a series which is like a must-take if you want to be get from 0 to 1 when it comes to the machine learning concepts. Moving on, Chip Huen's Guide to Machine Learning and Operation. I'll link down the website from which you can follow up and enhance your knowledge based on AI, ML, and lastly, faith and wisdom. Have faith, trust the process, because the thing is it's going to be very healthy and very overwhelming, and you have to trust your instincts, trust your gut, and I'm gonna make it through. I'll get that machine learning internship at a good Fortune 500 company, and that's pretty much it, folks. Thank you so much for the support. It's a great pleasure that you guys show your support, because support is what drives this channel. So yeah, that's pretty much it. I hope you enjoyed the video. Please do like, share, subscribe, and drop a follow on my socials. Socials will be listed down below. Until then, peace out. See ya. Bye bye. Take care. Happy coding.